So what is design intent? Design intent is a way, or it's your approach, like how you will create a solid model. For example, we have this model in front of us, and how to create it and what commands to follow is what design intent is. So here we have used two sketches to create this solid, and let's understand in how many ways this can be made and which one is the right way of doing it. So we have our model in which we have these two sketches only. So what we can do is we can simply use a revolve command. First we define this. After defining the part body, we simply use a revolve command, shaft command. We want a 360-degree revolve. What profile we want to revolve, we select here and we select the profile. And it is asking to select an axis. By default, it has taken the sketch axis, but make sure to select uh, the required axis, which is the Z axis. We click OK, and we got our profile. Comparing to the other profile that we saw earlier, it has a smooth edge here, and it also has a smooth edge here. So to achieve that, what we can do is we can provide fillets on this shaft, 2 millimeters. We can provide uh, to the two edges within the same command. So we got our first part done. Now we have our second sketch. We have defined the fillet. After defining it, what we are going to do is we are going to simply pad the sketch. We want the height to be 5 millimeters. We click OK. And here we got our desired model, which is very similar to what we are looking here. But there is a problem. The problem is we got this extra chunk of material that we need to remove. So how we are going to remove this extra chunk of material? What we can do is we can simply define this here, and we can extract this surface and we can trim away the extra material that we are seeing here. So we define it. We can go to the shape design workbench, but what I have done is I have customized my part workbench to have shape design commands. We select extract and we make sure that it is a tangent propagation and we select this surface. We got our desired surface. Now what we need to do is we need to trim away this extra chunk of material with the help of this surface. So we define the last solid operation in part body, and we use this command to trim away the extra chunk of material. It is split, and then we select the surface that we just extracted, and we make sure that these arrows on the outer side, and we just simply click OK. We hide it. We hide the surface. We hide the point and axis system, and here we got our desired result. So this is one way of doing it. But what if we don't want to use this surface? And in fact, it is considered a bad way or a bad intent for using surfaces to split extra material from a solid body. So what is there another way of doing it without using a extract surface or without going to the shape design workbench? So let's just delete this surface. We also delete the children that is split. and now we want to remove it. So how we can do it? What we can do it, we can use Boolean operation. To use Boolean operation, we must have more bodies, and we need to put this pad command. I'm going to cut it and I'm going to paste it in the other body. So we have moved the pad command for these tabs to another body. And now what we can do is, to use the Boolean operation, we actually don't need this sketch now, we can delete it. So to use the Boolean operation, we define the main part body, and we right click on the body in which the tabs are there. We right click on it, we go to body and we use union trim, and we choose faces to remove, and we select the surfaces or faces that we don't want, and we click OK. So we have achieved the same result using a Boolean operation instead of using a split surface in this design intent. So this is considered a better way of achieving the desired result instead of using a split surface or going to the shape design workbench and extracting the surface. What if we want to change the length of these tabs? So we can measure and check like what is the length of these tabs as of now. We select the z-axis and we select the edge of the tab. It is 68. Again we check it. It is 68. And for the third one also, it is 68 millimeters. What if we want to increase this length from 68 to 70, or we want to decrease it from 68 to 65? Let's try doing it. So we go to the pad feature, we define it, where we generated these three pads. We go to the sketch for the pads, and here we will try to increase the length of this tab by 2 millimeters. Say from 68 we want to change it to 70, and we press enter. And when we come out of it, when we come out of the sketch, we see that uh, there is some changes. And let's define the tree at the top, and let's check if the length of all the three tabs is changed. So we do our measurements and we find that it is not changed. It is still 68. Let's check for the other tab. It is 68. Here you can see the length is changed to 70. Now this is problematic because we actually don't want to go and change each and every profile to get the desired result. So this is considered again a bad intent. So what instead we can do is we don't create these profiles, and what we do is we uh, just ignore it. Or what we can do is, let's talk about manual update. So we turn on the update instead, and we close this for now. We go in the sketch, and we have done our changes. We want the length to be 70, and we exit it. So here it is showing a caution. There is an issue. Like when we are updating it, so it is not able to find the other two faces because we just now deleted it from the pad. So let's define the pad and see what we have. We have only one, but the trim command, it is looking for the other two faces. And to overcome this problem, we can just simply go to trim, and we can, just open this option. We select the only one face that we have, and we click OK. Now we define our main part, we do an update, and we have our tab, but we still want those two other tabs with the required length. So we define our pad and we do a circular pattern. Here is the command for circular pattern. We want it to be along the whole crown, and we want 3 instances, and we select the reference element, which is the z-axis. Click OK, and now we have created these 3 tabs as per our requirement. Again, we have to do an update. We do our update and we define our part body. You can see that one of the material is already removed, but still we have material on other 2 tabs. So we don't want this material. So we go to the trim command, we double click it, and we add these 2 faces to this faces to remove palette. So we select all these faces, and this face it is already selected. We click OK, and we can see that the extra material is removed. So in this design intent, though we have changed the length of one tab, and as we measure, now all the tabs they have the same length because we used a circular pattern outside the sketch. Now another benefit of using this circular pattern is in case we want 4 tabs instead of 3, we can just simply go here and we can change it to 4 and click OK. And we update the model. Now we have 4 tabs. Again, it is going to add this extra chunk of material, but this can be fixed by going into trim and adding this extra face to the command, and we click OK. Now it is having 4 tabs, and again, if we do any changes to this sketch, say if I want to reduce it to 65, I change it to 65 and I exit it, and again it is asking for an update. I update the model, and now when we measure, all the edges are at 65 millimeters from the center. So this is another way of getting the desired result. We actually needed 3, not 4, so let's change it back. Now it is saying that it is not able to find one face. Let's see what we can do. We edit the command, we close this, sorry, we update it, we go to edit, and we are fine with the 3 elements only. We don't need the 4th one. We click OK, and the model is updated with our desired results. So this is another way of getting the same model, but this is a better way since we are using a circular pattern outside the sketch and we are actually simplifying this sketch. The design intent, it should be as simple as possible and it should have as less steps in the specification tree as possible. So uh, why we need to have a simple sketch and simple procedure is because suppose if you are working on some model and later by the day someone else is going to come and work on your model. If your sketches are complex or your design tree is complex, it will become very hectic and difficult for the other person to understand what you have done. So we will try to simplify this sketch, and a good intent is that one sketch should have only one closed profile. So we don't want this sketch to have this circle, and we can actually delete it. And we don't want it to have these radiuses because we can provide it from outside the sketch. And we extend these edges to create a corner. Next is we need to constrain this properly. It is not properly constrained, so we give just one more dimension. Now the sketch is properly constrained. We don't need this dimension. Now when we come out of the sketch and we update it, we don't have the holes. But what we can do is we can add fillets to these edges. We should add these fillets right next to where this padded body is. Now what will happen, we will just provide fillets to one of the tab, and automatically the other two tabs, they will get their fillets. Because we are adding this fillet before the circular pattern, we click OK. It got the pads, and when we update it, you can see all the tabs got the fillets. Now we define the part body, but still our holes are missing. So what should we do? So to fix this problem, what we are going to do is we are going to insert another body, and we are going to insert a sketch inside that body. Make sure the freshly created body is defined. Now we need a circle of diameter 10, and we want it to be at 60 millimeters from center, and we want it to be aligned with the with the horizontal x-axis. So we select it, we click on the center, we click on the horizontal axis, we right click, and we got an option to coincide. We click that, and now it is coincided with the horizontal axis. We can move this a little inward because right now it is on the edge. We make it 58. Now we pad it, but see that we are in a different body. We are not going to pad in the main body. Here we are going to pad it both the directions. Okay, now what we can do is we can again add this remove feature. We actually want to remove this much chunk from all the tabs, and what we can do is we can define these fillets. Instead we can define this body here, and after defining it, we can right click on this newly created boss. We go to this option and we do a remove boolean operation. So it is always recommended to use boolean operation, and it is not recommended to use the negative operations like pocket or hole to create your desired solid model. Now once the remove operation is done, we can update the circular pattern. We can define it. After defining it, it is red. That means it is asking for an update. We right click and we do a local update. And now it can be seen that all of them, they have the holes. And when we define the main part body and we do a update, now we can see we got our desired model. Uh, if we say, if we want to change the length of this tab, if we want to change it from 65 to 70, we press enter, we exit it, and you can see that the whole model is asking for update. Let's update the remove boolean operation first. We define it and then we do a local update. We see that the hole is not moved along with the edge. We actually want this hole to be, uh, we want this center of this hole to be, say 7 millimeters away from this edge in any scenario. So let's once see the final model. We define the main part body and we do a local update, and we see that all the three holes, they are not in order. So how can we do it? How can we resolve this issue? Because we want this hole to be closer to the edge of this tab. So to resolve this issue, we go to the sketch of the hole, and we want to take reference from the sketch of this pad. We unhide the sketch and we hide this pad, and we use this command of project 3D element. We click on the edge, and now this element is projected into our defined sketch. We can hide the background from visualization tab. We select this option, no 3D background. So this is only our sketch, and this is the line, this is the edge of the tab from where we need a specific distance for this hole. We delete it, and we give this dimension here instead. From the center of the hole to this tab, we make it 7 millimeters because this is what is desired. The problem here is it is a solid line and it will not let us to create our sketch. It will create problems while creating solid body. Okay, contains several open contours. So this is the error that we are looking at. So to resolve this issue, we go to this sketch and we actually want it to be a reference line. So we convert it into a reference using this command from sketch tool. And now we exit the sketch. And now let's try updating the remove command. So we see that the hole is moved to the edge of the tab, and let's update the part body. And we can see that everything is fine. Now let's see if we want to reduce the length of this tab. We go to this sketch, the tab sketch, and we just decrease the length from 70 to say 68, which is desired. So the moment we change it to 68, you see that this has turned red, which was not the case earlier. It is turning red because now it is looking for an update. And because the edge of this sketch was a reference for this hole, which was in a different sketch, the moment we update the remove command, the sketch is automatically updated and the hole is moved. See, let's unhide the remove command and we define our part body. We give a local update, and it can be seen that we got our desired result. So this is a different design intent compared to the previous two design intents, but this intent is way better to customize easily, and this intent is also simple to understand from for anyone who might need to work on this part later when you leave the office. In the end, we can conclude that the 3D model that we create, it must be easy to understand by anyone. The sketch profiles we create, they must have a single close profile for the sake of simplicity. We should define relation between features such that any changes to one feature must automatically propagate the change to another related feature. The 3D model that we create must be easy to edit and easy to customize. And in the end, we should avoid using negative operations. Instead, we should use Boolean operations because it will make our specification tree uh, more simple. Thank you.